Let us discuss an important situation of earthing of a system of three parallel plates. Here we can see there are three large metal plates A, B and C, out of which the plate B is given a charge Q and outer plates A and C are connected to earth via two switches. Now say if we close down the switches and we are required to find the amount of charge which has flown through switches connected on A and C plates, then we need to analyze in a way which we have discussed in the previous sections that due to this connection, the very first thing which will happen is this charge Q will be divided on the two faces, but here it will not be equally divided because here we can see that the plate Q is at different separations from the plates A and C. Say it is distributed as plus Q1 and plus Q2, and in this situation obviously if it is connected to earth, the outer surface of the system will carry zero charges. On the facing plate it will be minus Q1 and on this plate it will be minus Q2. As we know that whole of the flux will terminate on the inner surface of the other plate, so its charge has to be equal and opposite to this. And here if we talk about the electric field, it will exist in the two directions as E1 and E2. And here value of electric field E1 we can simply write as Q1 by A epsilon naught and E2 can be written as Q2 by A epsilon naught, because we know that due to metal surface, if charge density is sigma, the electric field in front of the metal surface is sigma by epsilon naught. So in this situation, if these are the electric fields, uniform electric fields in front of the plate A and C, then here we can see that potential of earth connection is 0. So the potential difference of plate B with A and potential difference of plate B with C must be equal. If its potential is V, then we can simply state V minus 0 is equals to this V minus 0. So we can see that potential difference between plate AB must be equals to potential difference between plate CB, and as the electric fields are E1 and E2, the separation is D and 2D. Here we can write potential difference between A and B is E1 into D, and it must be equal to potential difference between B and C, that is E2 multiplied by 2D. So in this situation, if we substitute the values of E1 and E2, here we are going to get the relation Q1 is equals to 2Q2, as well as we are having a relation Q1 plus Q2 is equals to capital Q, because this total charge is divided on the two faces of plate B. And on simplifying this relation, we'll get the value of Q1 is equals to 2Q by 3 and Q2 is equals to Q by 3. That means on connection with earth, as if initially plate A and C are uncharged, here we can say the final charge on plate is minus Q1, which must be supplied by earth. That means on closing the switch, a charge 2Q by 3 is flown from plate to earth. That's why the final charge on plate is minus 2Q by 3. And on plate C, on closing the switch, as initially it was uncharged, a charge of Q by 3 is flown from plate to earth. That's why the final charge on plate is minus Q2, which is minus Q by 3. So these are the charges which are finally flown to earth due to earth connection. This is quite an important illustration to understand how the charge distribution takes place on a system of parallel plates if one or more plates are connected to earth.